one of the advantages of using this is that I can go back and figure out what each and every single data point or data value from my collection was. Now, if there was 5,000 different data values, would you want to use this kind of graph? With 5,000 different data values, this graph is going to be uncomplicatedly large, and it's going to be very complex, and it's not going to be very pretty to look at. Okay? So stem and leaf plots are primarily used when we have relatively small data sets. You don't want to use something like this with very large data sets because it's very cumbersome. It takes a lot of time to go through and sort all of the data and make sure it shows up everywhere in our stem and leaf. So primarily we're just going to use these for small data sets. Okay. All right. What's another graphical display we can use? Plots. Those come in a different context. We'll get to those later. Another kind of graphical display for quantitative data we can use is what's called a dot plot. And I'm not sure about how prevalent these are. I don't see a whole lot of these in the literature that often. Our authors like these, and so they include them in the book, and I will include them as well. These are, again, a way of displaying data that, like the stem and leaf plot, allows us, if we need to go back and construct the original data set based on the graph itself. Okay. Now, all a dot plot is it's a, as that graph was sort of vertically oriented, a dot plot is sort of a horizontally oriented picture. And we're going to use the same data set we have here to construct our dot plot. All a dot plot is it's like a number line with dots over each of the individual data values that we have. Okay. So let's see, 120, 30, 40, 50. Not going to work out well. 60, 70, 180, and we'll stop at the 180 range just because I don't have enough board space without deleting everything. In writing up a dot plot, all we're going to do is for each one of these different values, we're going to put a dot over where it would occur on this number line. Okay? For example, our first one we have 123. So I go to where I think 123 is approximately, and I'm just going to put a dot. There's the first value, 123. Do the same thing for 128. 128, right about here. I'm going to put a dot. Continue on through the rest of my data. I have 135 values, so I'm going to put a dot at 135. I have one at 143, about there. Another one at 147, right about there. A 150, a 153, a 161, two at 162. So I'm going to stack the dots on top of each other at that point, and then continue on in the same fashion. I have one over here at 185, and we'll stop there. So this is an example of what's called a dot plot. And again, all it is, it's a horizontal graph that basically does the same thing as the stem and leaf, only instead of using the actual numbers as part of my display, I treat each number as a dot. In terms of when to use one versus the other, it really just depends on what your preference is. Okay? This picture and that picture say the exact same thing, just different interpretations of it. All right, so that's our dot plot. The next one we're going to deal with is sort of the more popular display of quantitative data, and that is what is called a histogram. Now, I'm sure all of you have dealt with histograms before. These kind of pictures show up a lot in statistical analyses. A lot of times when you see pictures in the media, about quantitative data, they're usually accompanied by something like a histogram. A histogram is very similar to a bar chart, like what we saw with the categorical data. There are some major differences. Histograms are used for quantitative data. Bar graphs are used for categorical data. A histogram is basically just a visual representation of the frequency in which the quantitative variables show up. Picture of something like this, which we saw on Friday last week with the touchdown data, looks something like this. You get all of these little bars, they're next to each other, and we'll talk about sort of how to construct something like this. This is an example of what a histogram looks like. Across the vertical axis here is the frequency that the data shows up, and along the bottom here are what are called the classes. All right, so let us take a look back at the football data we had last time. Write that down if you need to. Okay, so last time we saw hit that like button, please. Thank you. All right, so last time we looked at this data right here, and again, this data represented the number of touchdowns that each of the 119 teams in the NCAA Division I scored in a particular year. All right, well, looking at this data, look at it, you say, okay, great. I got a bunch of numbers on a screen, and I don't really see the picture of what this data is trying to tell me. Okay? In statistics, what we're trying to do when we summarize data is we're trying to give it a voice. We're trying to say, what is the story that this data is telling us? Graphical displays are one way we can sort of put that story into usable ways. All right, so here's our data. I want to construct a graph based on this data. Well, all right, there's 119 values here. Do you want to construct a stem and leaf plot line? Okay, that'd be kind of a pain in the butt. 119 data values, it's going to take me a while to sort it all, and then to construct my graph, it's going to be somewhat long. I don't want to do that. For the same reason, I don't want to construct a dot plot with it. So how can I come up with a good way of displaying this in terms of a graph? Well, I can use a histogram. What my histogram is going to do is it's going to take this data and it's going to sort it. It's going to sort it in a way that allows me to get a picture that is usable. Okay? The first thing I have to do is I have to identify what are called classes. All a class is it's like a collection of these data values. You can think of it as an interval of the data values, starting at one value, ending at the other, and including all of the values in between. Okay? That's what the class is it's just a collection of these values that have been grouped together and defined as being one category or one class. Okay? All right, so how do we figure out what the classes are? Okay. First thing, we need what are called classes. Question 1, how big should the classes be? Okay. Question 2, along the same lines, how many classes? Now, in terms of the picture of the histogram, when we saw each one of these bars represents a different class. Okay? So when I talk about classes, this is what I'm talking about. I'm talking about each one of these individual bars. So how many of these individual bars should we have? Well, that's a good question. And in answering that question, this is sort of one of those instances where understanding whether your variable is discrete or continuous may become important. In this example, our football touchdowns. Our football touchdowns, are those discrete or continuous? Discrete. They're discrete, right? I could list out every possible number of touchdowns that a team could score in a year, and I can't score half a touchdown, I can't score a third of a touchdown. So in between 30 and 31, there's no additional values I have to worry about. Okay? So this is discrete data. All right, now one thing I could do is I could make each individual number of touchdowns its own class. So I could make 15. Number of teams that scored 15 touchdowns, that could be one class. Then the number of teams that scored 16 could be its own class. 17, 18, 19. I could do that. My graph would look terrible. It would be the length of the board. Some of them would be this big. Some of them might be this big. A lot of them would have no values. Okay. So maybe going with each individual one as its own class is not a good idea. What's that?
Groups of 10.
One thing we could do is we could group them in terms of groups of 10. Okay? So we might say, let's group all of the values between 0 and 10 together. Okay? So 0 and 10 all go in one category. Okay? What would the next category consist of?
11 to 20.
Are you sure? One thing that we need to be careful of when we're doing this is we have to make sure each one of these bars has exactly the same width. We don't want to put too much emphasis on one bar. For example, between 0 and 10, there are no teams that score between 0 and 10, right? What about between 11 and 20? Well, between 11 and 20, there may be 6. So then the next category would be between, 21 and 30, 11, 20, 21 and 30. Okay? How come I don't make one 11 to 20, and then maybe, I don't know, 20 to 40?
You'd have more likely to have more teams in it.
Right. If we increase the sizes of these classes, what that causes us to do is it causes us to put too much emphasis on that individual group. And we don't want to do that. We want each group here to represent the same, to have the same opportunity of being represented in our graph. We don't want to put too much emphasis on one class or another. So all of our classes have to have the exact same width, or the exact same number of possible values showing up in that group. Okay. So, if we're going to start at 0 and go to something, it'd probably be better to start at 0 and to go to 9. 0 to 9. There are 10 values that could happen in there, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So 0 to 9 would be the first class. The second one would then be from 10 to 19. The next one would be from 20 to 29. And so on and so forth. We want to make sure that all of our classes have the same width. All right. Got that done. We can do that. Okay. The next question is, how many classes should we use? Well, how about we just use one class, and we'll go between 15 and 85. Yeah. And we'll draw a picture of the frequency of showing up between 15 and 85. Well, there's 119 values in that category. That's not a very interesting picture. Okay. One category, everything falls into it. Not a very interesting picture. Doesn't tell us a whole lot about this data. Okay. There's no specification for how many classes you have to have when you construct a histogram. There's no steadfast rule that says if your data has this many values, you need to have this many classes. There is no steadfast rule like that. There are recommendations, and lots of books give different recommendations. The authors of our book recommend that you have between 5 and 10 classes. Okay? So the number of classes you construct is really ultimately up to you. It depends on how much you want to work in constructing this particular picture. Okay? There's also, as we change the number of classes, the picture that we get may change a little as well. Okay? So ultimately, to figure out the number of classes you want, you need to sort of figure out what story do I want this data to tell me. How do I best convey that story by choosing the appropriate number of